Oh, good day, everyone. It is my pleasure, Dr. Wynand Louw, to welcome you to the second day of our CIPM workshop on the SI in fair digital data. I know that many of you already joined us yesterday, but let me just give you a quick background of why we have this workshop on findable, accessible, interoperable, and reusable data. In the first place, you're seeing my face because I'm the chair for today, and I have with me as co-chair Dr. Noah Emad Khaled, the president of NIS in Egypt. So we will host you today. I also need today to welcome you on behalf of the chair of AFRIMETS, Professor Mohammed Amer, that unfortunately had COVID. He's already out of hospital, but he's not well enough yet to join us. And we wish him all the best. We hope that he's watching today, and we wish him all the best. So I think many of you know me. I'm from the National Metrology Institute of South Africa, NMISA, and I was one of the people that started AFRIMETS in 2007 and was the first chair 2007 to 2011. And I'm a physicist, and I was selected to the CIPM, the International Committee for Weights and Measures, in 2013. And then in 2019, I was elected as the president. So I'm also the president of the CIPM. But then, on behalf of Professor Mohammed Amer, can I welcome all the regional metrology organization people? In the first place, EURAMET. Already, many of you joined us yesterday for the first day already. And then COOMET. Welcome everyone from the COOMET region. And then our own region, AFRIMETS. Colleagues, thank you so much for joining us, and we hope you enjoy the day with us. Already yesterday, we had the questions, how is the CIPM going to manage the whole situation with developing and developed countries when we talk about digitalization? And so it's very important today that after you've gotten the background on what we are talking about, that you then also give input and ask us questions about this topic. But we really hope you will enjoy the day with us. Let me now introduce the speakers of the first session to you. As you know, we have two sessions today. The first one, then we will have a break, and then we are going to have the second session. So I think the first thing to say is just for you to know that the room will be closed in the break. So we will have this first session, finish with the discussion, then the room is going to be closed, and then the room will reopen after the break for the second session. So the speakers today, we are very privileged to have our good speakers with us, and you will hear their recorded presentations shortly. In the first place, Simon Cox is going to talk to us about the digital units of measure services. And Dr. Cox works on practices and standards for publication and transfer of science data, particularly geospatial. After starting his career in geophysics and mineral exploration, he became involved in data and informatics and is principal or co-author of a number of international standards for data. His current focus is on fair data, linked open data, and semantic web technologies. He is a member of several national standards committees in Australia and is on the executive committee of CODATA. We are looking forward to that presentation. He will also be assisted by Kai Bloomberg, and Kai Bloomberg is an ontologist at the Biological and Chemical Oceanography Data Management Office at the Woods Hole Oceanographic Institution. He's also a PhD candidate in the Department of Biosystems Engineering at the University of Arizona. And Kai works on various open source ontologies to promote environmental data interoperability. And you will hear everything from them later. Then our next presentation is by Eric Schultes, and he talks on fair implementations, networks, and data points. Now, Dr. Schultes is the International Science Coordinator at the GeoFair International Support and Coordination Office. He's also a member of the Leiden Center for Data Science. In recent years, Eric has been working with a diverse community of stakeholders to develop fair data and services within and outside the life sciences. Then our third presentation this morning is by Sarah Jones on the EOSC Interoperability Framework, facilitating cross-domain discovery and reuse. Quite a mouthful. Sarah has worked in the field of open science and research data management for the past decade. Previously, she worked as Associate Director at the Digital Curation Center, and in July 2020 began at Adjunct as EOSC Engagement Manager. She has been involved in several European Commission-funded projects, such as EU DAT, Open Air, and FAIR. I hope I said it correctly, Sarah. And she worked on the expert groups for FAIR data and a transport research cloud, and was an independent expert on the EOSC Executive Board. For RDA, she is co-chair of two groups, Active Data Management Plans Interest Group and the Global Open Research Commons Interest Group. Everyone, with that, enjoy the day with us, and we are looking forward to your input later. We will now basically go to the first presentation. Thank you.
Hello, I'm Simon Cox from CSIRO, which is Australia's National Applied Research Organisation. My presentation is on digital units of measure services, communities, coverage, and alignment. So here's an outline of what I'll be telling you about today. I'll be introducing and reviewing a number of existing digital units of measure systems. Why is there more than one? Well, this is related to their origins in different communities and different applications who have different interests and scope. Also, there have been a few different technologies and different levels of adoption, both within and outside the originating community. Finally, I'll make some comments on the potential for harmonization and what is already going on in alignments. Why is this relevant to digital SI? Well, I guess this should be obvious, but just in case, SI is just a subset of all the units of measure that are in use. It is the most important rational subset and is almost always used as the bridge between other systems, such that pretty much all other systems of units, even in the US now, are now defined as scaled versions of SI. There are also many existing digital machine-readable units of measure representations. To understand if we can make use of them, we need first to understand a bit about their scope and technology, and importantly, where they come from, which applications and communities built them. I'm going to describe three systems in detail and then summarize several more. First off, the Unified Code for Units of Measure, or Eucom. Eucom is an implementation of and direct successor to a series of standards that aimed to define codes for units of measure that, on the one hand, look like the usual scientific codes, but on the other hand, can be typed on a standard keyboard. Some of you will recognize the names of the predecessors. None of these was complete or fully consistent, so starting in 1998, Eucom has attempted to rationalize them. It is primarily the work of two heroic souls, Gunther Schadow and Clem MacDonald, and is formally owned by the Regenstrief Institute, which, despite its odd name, is part of the US National Library of Medicine. Here's the summary of what Eucom does. Note that the symbols that are not available on a standard keyboard are approximated. The base symbols can be combined with prefixes for compound or multiple units, for example, decagray and femtomole, milliliter, centimeter, or by multiplying or dividing them or raising them to integer powers for derived units. Non-SI terminals are also available, for example, colony forming units, percent, gray. Qualifier suffixes are in square brackets, for example, centimeters of mercury, and annotation suffixes, which don't actually change the values, the conversion factors, are in braces, e.g., for example, percent volume. The definitions table includes the conversion factor 2SI for each atom, which allows any quantity scaled with a valid Eucom code to be converted. The formal definition of Eucom is a Backus-Naur production rule, which can be implemented using the finite state machine shown on the right. The Eucom dataset is an XML document. You can see the small amount of detail required for each definition here. As I mentioned previously, Eucom comes from the health and clinical medicine application space. Eucom is built into HL7's FHIR system, which is widely used in clinical settings. There are also some validation and quantities conversion services available. There I've shown both the user interface and the service descriptions. Eucom is considered essentially complete, but there is a public maintenance process managed through a track ticketing system. Fixes and enhancements are still occasionally made, but note that because Eucom defines a generative algorithm for derived units, it does not require an update or new release just to add a new derived unit code, which only uses existing atoms. Next, the QUDT, Quantities, Units, Dimensions and Types system, originally from NASA and Top Quadrant. QUDT actually came about following the issues with units that contributed to the Mars lander accident. QUDT now has its own organization, though Top Quadrant still supports it. The QUDT model links units to quantity kinds to give the semantics and dimension vectors to give the physics, if you like, within the systems. This diagram is just to give a sense of the level of detail that is supported by QUDT, as it also includes recording the symbols and codes from various symbol systems, including LaTeX, UNECE, and Eucom, and also offsets and multipliers relative to SI required for conversions. QUDT publishes a series of collections, one for each type from the model. So there is a set of quantity kinds, a set of dimension vectors, and a set of actual units, as well as these other pieces. Here's the top of the units catalogue, showing the A's. Symbols like unit : A-per-M are shorthand for URIs, which are persistent web identifiers. The actual URI for that unit I just read out is shown at the top of this example entry, and the whole entry shows the detail available for each entry, including the Eucom code. QUDT is implemented in AL2 and also in Shackle. Maintenance is tracked in a public GitHub repository. New releases occur approximately monthly, typically with 1 to 10 new units, plus other fixes. QUDT came from engineering applications and has been adopted in a number of engineering and manufacturing contexts, as well as some science areas. The Nerc vocabulary service includes one collection of units of measure, known as P06. The Nerc Vocabulary Service, or NVS, is a big vocabulary service which is an important part of the marine science and oceanography infrastructure. The oceans community tends to be quite good at establishing and maintaining shared infrastructure, probably because their kit is big and expensive, therefore usually shared. We're talking about ships and global constellations of sensor platforms. NVS has around 300 separate vocabularies, of which P06 is just one. Some of these vocabularies are very large. For example, the notorious P01 has around 50,000 terms in it. P06 is essentially an inventory of units that are used in actual data sets. It is not designed to be fundamental or comprehensive, so there are sometimes surprising omissions. For example, P06 includes knots, nautical miles per hour, but nautical miles is not there because no data sets measure distance in nautical miles. Here is one of the entries from P06. A key point here is that it is not a fully structured unit definition, just a name, identifier, and textual description, together with a large set of links to related terms in other NVS vocabularies, mostly to terms in the Observable Properties inventory, that is the quantity kinds that use this unit. The simplicity of the representation is because this collection of terms is formalized in SCOS. SCOS is the standard formalization of all the definitions of NVS. And here's the SCOS serialization of becquerels per kilogram. Note that there is also a link to the QUDT definition, so a formal structured definition could be got to from here. As mentioned, NVS comes from the international marine science and oceanography community. It is comprehensively used in operational systems within that community, particularly by the European members. But NVS is also used as a reference point for definitions by the entire international Earth and environment science community. So that was an overview of 3 of the key systems for digital representation of units of measurement. Each of the ones I showed has got quite a long heritage and also significant adoption and implementation in one or other community. Eucom in health and clinical medicine, particularly in HL7 fire, QUDT in engineering and science, and NVS P06 in marine science and oceanography. However, there are a few other systems that are worth mentioning. OM, UO, and Suite are all OWL ontologies. They come from science communities. While they're not necessarily implemented in operational systems, they are the basis of a lot of analysis and investigation amongst ontologists and in experimental systems supporting science data. OM is hosted at Wageningen. UO is part of the Open Biomedical Ontologies, or OBO Foundry. And Suite was originally also developed at NASA, but is now maintained by the Earth Science Information Partners, which is funded through NASA, NOAA, and the USGS. Moving on to a bit of analysis and consideration of why so many, and is there anything to be done about it? First, some statistics. Here I've just counted the number of units in each system, plus a few other types where I think they are interesting. Eucom is in principle the most parsimonious, as it only has the unit atoms that can then be combined to build an unlimited set of derived units, but there are still 310 entries. QUDT is the biggest in this survey at 1700. However, 350 of these units are either currencies, oh dear, or multiples or submultiples of simple units. QUDT also has substantial catalogues of more than 800 quantity kinds and around 200 dimension vectors. OM has almost as many units as QUDT with more than 1400, but as well as currencies, yikes again, it also includes a lot more multiples and submultiples, since it exhaustively enumerates all the petas and yotas and attos and femtos and yoctos of many basic units, even though they would rarely, if ever, be seen or used. Suite is just an inventory of 138 units that the editors had come across in Earth Science. And similarly, P06 is an inventory of 375 units that appear in marine datasets. Finally, UO is a set of 597 units from biomedicine. Surely these could be replaced by one system. Well, yes, the theory to describe a unit of measurement is straightforward, and the models show the same classes, sometimes with slightly different names, but are easy to transform. However, the prospect of harmonization to a single system, I don't see that as practical or necessarily even desirable to imagine that the systems can be replaced anytime soon. Some of them are built into big operational systems with a significant investment, and they work well enough, so why would the operators replace them? However, there is definitely no need for any new systems, so we need to advertise the existence of these. And as long as we can keep the numbers down, fewer than 10, say, then one-to-one mappings between them can probably be maintained. And there has been some progress on alignment. There are now mappings from all of the systems to Eucom and from several of them to QUDT. I've been involved in building many of these mappings. The rationale for using Eucom and QUDT as the core for alignments is that the Eucom codes are unique textual identifiers, so can be used as keys for joins. And QUDT, having a full semantic model, able to describe derived units as well as the fundamental ones, and is also the most responsive to update requests. Adding a new unit, or addition of a new unit, can be processed in a few days, and there is a formal release of QUDT round about monthly. So what have I told you? There are a number of existing systems for digital descriptions of units of measurement with various levels of modeling and formality. Most of these are potentially fully general, though the exact inventory and implementation in each are grounded in a specific community. Eucom being purely generative, while the others each persist an essentially arbitrary suite of derived units representing an inventory of units used in a suite of applications within the specified community. There are some alignment efforts underway, primarily based on using Eucom as the textual key and QUDT for rapid publication of U units for bridging purposes. I think that's probably enough for now. I'm done. Thank you.
Hello, my name is Eric Schultes. I'm the FAIR Implementation Coordinator at the Go FAIR Foundation here in Leiden, the Netherlands. And I'm very happy to be with you today at the FAIR Systems of Units conference and workshop. And I would like to tell you today about recent work we've done on making FAIR metadata and making it easy for people to make FAIR metadata. And our interest in incorporating FAIR SI into the work that we're doing. And this is, by the way, all in the context of the Dutch COVID-19 research program. So this is really work that's been built up in a very urgent way over the last year. And so I'll try and take you through that process and see how we are trying to focus in on fair system of units. And before we get into the details, I want to certainly acknowledge the hard work and the great efforts of a team of people that are working to create an easy pathway for domain experts to create the metadata that they need to express their data in increasingly fair ways. And I want to highlight in particular the work of Barbara and Nicola, whose work I will draw on pretty heavily in this presentation. And I also wanted to mention that the work that I'm presenting, although very focused in a use case on COVID-19 in a Dutch setting, is actually part of a much larger verification framework. And I won't go into details on this today, but I have a link here so you can see that the things we're trying to do with metadata actually fit into a larger verification framework. So let's begin with the COVID-19 data portal project. So this is a national research program in the Netherlands, launched in urgency with lightning speed to research and make progress on COVID-19 related issues. There's two notable characteristics about this funding program that are quite extraordinary, quite innovative. The first is that there's a mandate within the ZonMV research program that research outputs are to be made fair. So that's a pretty strong mandate, but it's backed up by, number two, the support for fair data stewardship, both at the level of the PI. So that's this, I mentioned here, this 5% discretionary budget available to the PI for fair data stewardship issues. But then there's a larger project in the background that's working to create tools and services and methods that enable fair data stewardship. And I have a quotation here by Margreet Bloemer, who's the architect of this COVID-19 research program. And so to get into the content here, it's very nice to focus at the beginning on the FAIR principles themselves. And what you see immediately when you look at the principles is that metadata is everywhere. And I think the FAIR principles have done a great job elevating the idea of metadata to be really a first-class citizen with the data itself. And just in December, both Mark Wilkinson and Mark Mewson independently mentioned to me that FAIR is 90% metadata. And so I asked them if I could use this quote, and they said, sure, go ahead. So from these experts, we can see that metadata is in fact gonna take us a long way down the road to fairness. I also wanted to highlight principle R 1.3, which asks us to focus on domain relevant community standards for both data and metadata. And this is what really inspired and took us into this idea of metadata for machine workshops. Because although domain experts are required to create their domain relevant community standards, in most domains, most experts are probably not experts themselves in metadata, and maybe not, or certainly not in most cases, are they experts in machine actionable metadata. So the metadata for machine workshop idea was to say, well, if we want increasingly for domain experts to use and to create fair metadata, then we probably need to team them up with experts in fair metadata. And in a kind of hackathon environment, they could be able to produce the vocabularies and the metadata schema that are required to lift their data assets to a very high level of fairness. And what that means is that these metadata components are themselves fair at a technical level, that they fulfill the domain specific requirements. And we know that's the case because we have the domain expert in the workshop, and that these outputs, these vocabularies and metadata schema are themselves reusable. And we think if that's the case, if these three conditions hold, then we should be able to see the creation and then the widespread adoption and reuse of useful, fair metadata components. And in this workshop environment over the last couple of years, we've drawn on several different tooling and research groups that have been working to perfect methods in fair metadata. And I'll show how that looks in the presentation. And what I want to mention today is that we'd like to try and get to fair SI units as a part of our work in metadata for machine workshops. And for this, we're looking at the moment at the QDT standards, and I'll show you how that looks. So the metadata for machine workshops that we launched for the ZoneMV COVID program began last September, October, and it was really in November that we launched 6 metadata for machine workshops. We distributed the 62 research projects in the COVID program over these workshops. And you can see them listed there in terms of the number of people, number of projects. And in each case, in these workshops in November, we had the research domain experts and a data steward help us brainstorm on what we call project assets. So anything related to the project that needed to be described by metadata, such as data, biomaterials, services, standards, we went through very controlled, very structured brainstorm sessions using a tool called Padlet. This was all done online, of course. And what this allowed us to do is pull out of the domain expert the preferred terminologies that describe their research assets. And now what we've done in February is we've run an additional couple of workshops where we've been able to consolidate that list of terminologies, and we've begun building a formal vocabulary that describes these things. And in this, we've been linking to the existing vocabularies in BioPortal, ontology repository, and we've been using tooling that we've developed in what's called a FAIR data collective. And the ultimate goal here is to produce a COVID-19 research program vocabulary agreed upon by all 62 research projects, and that vocabulary would be available then for the CDAR workbench, which is a very nice tool that allows you to compose metadata templates in kind of a modular format. And then these templates become shareable as simple web forms or through APIs. And then either machines or humans can populate these templates and create metadata instances for different data sets, for different projects, etc. And what we will ask the data stewards in the COVID program, our Dutch data stewards, we will ask them to work closely in support of the researchers to help get these forms more and more routinely filled in, and thus creating metadata assets for the research project. And these metadata and the data themselves will then be put onto a network of FAIR data points and made available in a fair way. That's the COVID-19 research program, and this is some of the tooling we're using to try and create reusable metadata components. And I just wanted to mention, though, that above and beyond this one instance of COVID-19 research for ZoneMV, there are other metadata for machine workshops that we're running, some of them COVID related. And so you can begin to see that there should be automatically now a great deal of overlap that we can reuse vocabulary and templates from previous metadata for machine workshops. But it may be surprising for some that we can even reuse quite heavily components that are created in completely different domains. So for example, with the Danish group, we've run metadata for machine workshops 5 and 6 based on wind energy data sets. And in fact, we are repurposing quite heavily from wind energy domain in the COVID domain. But this is all in an effort to try and to get reusable metadata components and to not have to reinvent the wheel each time. And by using these components, we can better guarantee interoperability and fairness. So coming back then to these metadata templates that we created as part of the COVID-19 program during November and February, there's really 3 templates here that we have. We call it at the top, you see the project administrative metadata template. In the middle is the project content metadata template. And at the bottom is the generic dataset metadata template. These are links to the templates themselves. As you can imagine, the project admin metadata is just very high level. I think there's 22 fields that are requesting very basic information about the project. So the PIs, the funding agency, the grant number, et cetera. The content metadata template in the middle is starting to give an overview of the scientific content of the research project itself. But again, at a very high level. But that project content metadata could point to data set metadata, so that we have a quite extensive template for any data set that might be created in the course of these research projects. And I want to zoom in on this, on the generic data set metadata template. And you can see for yourself at this link at the top at OpenView. But you can see here a bunch of fields. I think there's 90 fields total, although a very small number like 10 or 12 are required. But you can see these are general types of fields that can describe and be applicable to any kind of data set. And I want to highlight then this one particular field called variable. And this is a very modular component of the metadata template that basically asks, what did you measure? Describe that measurement you made. And although we have a model behind this now, it's very straightforward, very simple. As the iAdopt group at RDA finishes its work on creating a more elaborate data model for what they call observable properties, we will almost certainly be using this as well. Here's a deeper view of the iAdopt observable properties. And so what you can see is that the observable property, so the thing that you're measuring, can be characterized by observed object, observed property of that object. And there's modifiers, including measurements and units and units of measure. And we will be extending, or let's say adopting vocabularies for this model from the QDT unit and QDT quantity kind vocabulary. And so here's an example of a generic dataset metadata template. This is a CDAR template. In this case, this is for a COVID-related measurement, like average physical exercise duration per day. We are observing time. This is for physical exercise for humans. This is measured per day. We're looking at the average, and our unit of measure is an hour. And we will take that unit of measure description from the QDT vocabulary. And so what you can see then is that this CDAR form is going to contain within it drop-down menus that allow the researcher to be able to select from fair or verified units of measure in a very direct way, helping to structure and make machine readable the metadata that's being input. Here's some other observable properties in the COVID program that we've procured from our data stewards. And the hope here is that we will be able to embed in these CDAR metadata templates QDT units for a range of different measurements, like concentration of virus and saliva, blood pressure readings, weight, length, body mass index, etc. And once we have these templates, then the exciting part is that we are able to then repurpose these templates and the vocabularies that they're using for other projects and other research domains. And so, for example, the Wellcome Trust and ZoneMV are now committing to the next generation of metadata for machine workshops, not only in the COVID space, but in other biomedical and research domains. This is also true for the Danish E-Infrastructure Corporation. There's a metadata for machine workshop in April on bioimaging. We will have another workshop later in the spring on carbon credit technology. And then the Health Research Board of Ireland is also now more interested in running a metadata for machine workshop for COVID-related topics. And the idea here is that what we would like to do is have reusable metadata templates that are using these FAIR units of measure, and that are becoming more and more mandated in their use by the funding agencies themselves. And we hope that this combination of these CDAR templates with the funders in these research projects will help to further the uptake and the widespread use of FAIR system of units in the future. Thank you.
Hi, I'm Sarah Jones from Géant, and I've been asked to speak to you about the EOSC Interoperability Framework and how that's facilitating cross-domain discovery and reuse in the European context. So first off, I wanted to explain a little about what EOSC is. So EOSC stands for the European Open Science Cloud, and it's an initiative led by the European Commission, which is creating a web of FAIR data and services. So what we're doing is federating the different e-infrastructure and research infrastructures across Europe to provide an environment in which data can be brought together with all the services to perform the analysis and enable researchers to address societal challenges because they can get all the relevant data from the different spaces. So you can see in the visual on the right here, the basic kind of architecture of EOSC. We have a core set of services, so things around AAI, so authentication and access, around the persistent identifiers and metrics and help desk services. And then what we're doing is federating both data from different repositories and different communities. And we have this EOSC exchange layer where a range of other resources and services are brought together to enable researchers to choose those to act on those data sets. So the aim of EOSC is to enable multidisciplinary discovery and reuse. At the moment, we have a number of research clusters and infrastructures, and if researchers want to use data from other spaces, they'll need to consult with services and repositories in different areas and bring the data together manually. And the EOSC vision is to federate these disconnected silos so that we can have one environment in which researchers are able to find all the relevant data and then to act on that as well. And this is part of a broader vision. The EC is signing a number of European partnerships at the moment and investing in a number of data spaces. So in the areas of agricultural data, for example, or energy or the Green Deal. And EOSC is a horizontal that cuts across these, that's addressing all different research communities, and we're aligning with these different data spaces. So what I want to focus on in this presentation is the interoperability framework. This is something that's been developed through the current EOSC governance. There are a series of working groups that were established, and the architecture and the FAIR working groups came together to develop the interoperability framework. And you can see how this fits into that overall model of EOSC, and that it's really a layer to help us bring together all the different types of outputs, so not just data, but publications, software, and services, and to interoperate between those. The interoperability framework has FAIR at its core, so this is a key concept for EOSC. We want to make sure that all the objects within EOSC are fair, that we can discover them, we understand the permissions that are assigned to those, and they're conforming to community standards so that we're able to reuse. So this is a kind of core premise that runs through the interoperability framework. The main report has been published and is now available on the EC's portal. And you've got the DOI there, so you can go and download that. And there are a couple of additional files that we made available. One of the things that came back when we consulted on the initial recommendations was the need to develop a reference architecture. Now, the group that was doing this was, a volunteer group. It was through a working group that people were committing resource to, through their own organizations. So some preliminary work has been done here to do a basic reference architecture around the digital object framework. So looking at fair digital objects and what's needed for implementation of those. This needs to be extended, and it also needs to address the service angle. We also started a preliminary metadata mapping where we looked at the different kind of standards that are in place across the communities and the key standards for resource discovery. And I've done a mapping between those to start to think about a kind of minimal metadata model that can be used within EOSC. So within the interoperability framework, there are 4 layers that are addressed. And this takes its idea from the European Interoperability Framework, which was used for public resources. And it applies them to EOSC. So we address the legal interoperability, so thinking about the different legislative contexts in each of the member states and associated countries, and addressing issues of copyright and data protection and GDPR, and how we align those when there are differences across the different contexts. There's also a strong focus on licensing. Licenses are clearly critical for all of the digital objects, so we know who has permission to use those and under what restrictions. We then address organizational interoperability. So this is looking at aspects of governance and also the rules of participation. There are a set of rules of participation for EOSC at large that look at the requirements for the different service providers and also for the different users. And then the aspects that I think are of more interest to the audience today are semantic interoperability and the technical interoperability. So with semantic interoperability, there's a strong focus here on metadata and ontologies naturally, and interpreting the meaning of these, so understanding when people are using common terms, whether they do in fact mean the same thing or if those terms are used in a different way in different contexts. With the technical interoperability, this is looking at the infrastructure at large and how we can interoperate between the different technical building blocks. So to give you a few example recommendations, we are calling for open specifications for all EOS services so that we know the regulations on those services and we can understand those. We call for coarse-grained and fine-grained dataset and other research object search tools, so people can search for a general topic, or they could search for a specific gene, for example, and find the relevant content. In order to deliver this, we do need clear, publicly available definitions for all concepts, metadata, and data schema. And we're trying to define this minimum metadata model and crosswalks to ease discovery over the federated data. Now, beyond that basic discovery layer, we do also need repositories of semantic artifacts, and we need to understand how these different ontologies are being governed and maintained and updated. And in terms of the licensing and the legal aspects, we call for standard human and machine readable licenses. We want permissive licenses, particularly for the metadata to aid the discovery, but ideally for the objects themselves as well. And in this context, CC0 is preferred over CC BY. So to dig in a little bit on the semantic interoperability implementation, there are a few layers to this. Obviously, we need the metadata catalog and the crosswalk so that we can have this common search. But we also need semantic artifact catalogs. We need to understand the different ontologies and what's meant by those different terms that are being used. And critical to this is the mapping repository so that we understand, one standard and how it aligns with another. Within the interoperability framework, there's a semantic use case that's presented, and I just wanted to provide that to you here. So a rare disease researcher, for example, is seeking clinical data. And they want to ensure that that data matches the current study population and the variables that are being interrogated. What they're trying to do is reach a population size that's needed, so increasing the size of the cohort. So they can search the metadata catalog to find candidate datasets, but then they need to go beyond that basic discovery layer, and they need to search semantic artifacts, which are based on the different domain metadata schema, to check whether the relevant variables are present, and if so, then they can include those in their search. So this is how they're agreeing a subset of data to reuse and to bring all that together within the EOS context. As I mentioned before, the FAIR and Architecture Working Group started a basic metadata mapping. So this was looking at the common kind of discovery standards that are used, like Dublin Core, schema.org, DCAT, DDI, and they've proposed some mandatory and optional elements that can help us with FAIR digital objects. You can see the mandatory elements are very minimal here. So obviously we need persistent identifiers. We need the basic metadata that lets us know who's created the resource, what it is, when it was published, the resource type, and the licensing conditions, so we know how that can be reused. And then there are a number of optional elements as well. And one thing I'd like to stress here is that we're really focusing on developing crosswalks, not developing a new standard. We realize that there are lots of existing standards in use by the research communities, and we want to support their use within the EOS context. So really we need to map between them all rather than implementing anything new that adds a burden to the research groups. This was a key lesson from the EOS pilot project. They had tried to specify minimum information for EOS datasets, but there was quite a pushback from the community. Now, what we've done here, this mapping is very preliminary. This is not an end result. There needs to be a concerted piece of work to develop this further and to do a lot of consultation with the research communities. And that's something that will happen under the next round of EOS projects that are just getting started in the coming months. I did want to show one example of how this has already been done, though, on previous projects. The IVOA, the Virtual Observatory in Astronomy, has been integrated into the UDAP V2Find service. So what they've done is they've exposed their VO data using OAI PMH as a protocol to pull that out, and the Dublin Core standard, so that they were able to be integrated into this common search in V2Find, which is a kind of repository and discovery layer that UDAT offers. And then you can see there's various kind of keywords and publishers and resource types that are focused on the astronomy community. So there's a disciplinary extension to that metadata schema that's based on the astronomy standards and data. So this is the kind of model that needs to be taken further within EOS to enable that kind of search and discovery that we're hoping for. So the next step then is implementing this into the EOS portal. The portal is the main catalogue and marketplace where researchers can discover services and data sets. And we'll be taking all of the work that's gone on in previous projects and through the EOS Interoperability Framework and implementing that within the portal. And the next project that's coming up, which will be addressing this, is EOS Future. This is a multi-million euro investment with several partners. It brings together all of the e-infrastructures and the research infrastructures, and it will be addressing that discovery, but also the composability of resources. So enabling people to bring together all of the relevant data sets with the services they need to act on those. And there are different aspects of composability that will be addressed. It may be that, you know, a service provider wants to integrate with the common federated AAI to enable easy log-on to multiple services and not requiring researchers to use different mechanisms for access. Or what's of more interest is this kind of D arrow here, the composability and bringing together of data between different research clusters or communities. Now, this has happened within research clusters, that they've integrated data sets from different research fields, but cross-community is where we really need to enable that to address some of those societal challenges. So there are a number of science projects that will be worked on addressing key concerns like aging population, climate change, and smart cities, and the COVID pandemic. And that's where we'll be looking to enable that metadata exchange. Now, I mentioned this this project is still to begin, and I mentioned this now because within the EOS context, there's some basic discovery, but I think this ability to map between the different units and the values is a much bigger challenge, and it's something that really we're only just making a start on now. So that's a summary of what's been done within the EOS context and what's coming. Thank you very much for your attention.
Thank you very much, everyone. We had 3 excellent talks from our colleagues here, Sarah, Eric, and Simon. We now have a discussion session for about 15 minutes. And for that, and to lead us through the questions, I am going to give over to Professor Noah Emad Khaled. Noah, please.
Okay, welcome everyone. Welcome, dear participants. I'm glad I'm with you in this very interesting, fascinating workshop. Thanks for all speakers for very interesting talks. And please, audience, if you have any question, we have already a few questions. If you have any extra question, please place it in the chat window. And now we're going to start with the question we already have. We have the first question. It isn't exactly obvious to whom, but it is from Holger. The question is, can you please say a bit more about on the EOSC pilot experience?
Yeah, so hopefully you can hear me okay. So the main thing that had come out of that EOS pilot project in terms of when we're thinking about the semantics was the issue that research communities really need to be able to continue working with their existing standards. So they'd been pushed back on, you know, having a different standard for EOS, which is why we focused on mapping across the existing standards when we're federating the different infrastructure.
Okay, thank you, Sarah. And the second question is for Simon. One of the challenges for mapping QUDT, NVS, and UCUM are compatible and from metrology view correct definitions of the units. Regarding the SI, we had the redefinition of based units in 2018. Do you think that the major unit representation schemes you have presented already to unambiguously provides a different definition through history?
That's an interesting question. I would say that most of these schemes are struggling to provide a good web experience, particularly a proper machine connections with different with content negotiation for different representations. So given that they're really in relatively early phase of getting that right, that question is asking really for a level of sophistication, which would be the next step, saying that being able to provide essentially, if you like, snapshots of what the official definitions of the SI units were at different points in history. I can see that would be a challenge at this point. You know, in terms of the system's currency, in fact, I'm on the technical advisory committee of Eucom, and I recently checked and found that in fact the
we can't hear
of the
Simon, please.
Oh, sorry, of the fundamental constants had not been updated to reflect the 2018
we lost you, Simon.
co-data work. And so, but that's being processed now. So you know, there does need to be first some attention paid to ensure that the different systems, in fact, even represent the current state, our current understanding as best as they could be. I think the point that Daniel. Sorry. Okay. Right. Yeah, I would be a little skeptical as to whether the systems are ready to give a historic viewpoint at this stage.
Thank you, Simon. Now we have another question from Mr. Ahmed saying, what is meant by GDPR and what is a needed license for that?
Looks like she might have frozen.
I think it's for Miss Sarah.
Sorry, so that's one I can take. The GDPR is a general data protection regulation. So it's essentially about when you're working with human subjects or sensitive data and making sure that identities are protected. So it's new legislation that came in a few years ago across all of Europe, and it tries to standardize those regulations. So in terms of licensing, it's slightly different because it's about protecting the individuals, but obviously it does have an effect on who could use the data and for what purposes, and making sure you've got the appropriate permissions for any subsequent reuse.
Thank you, Sarah. Another question from Martin Sin. Fascinating presentations showing the value and power of these different approaches, examples. I didn't spot any mention of uncertainty associated with measurements in any of these examples. Would the panel like to comment on this? Anyone would like to answer this, to respond to this point?
No, Imad, could you summarize the point again? I missed it.
The question is talking about no mention for uncertainty associated with measurements in any of the examples have been presented. They need a comment on this point.
Okay, so a comment on specific examples, I guess, is the question. Is that right?
No, not a specific example. He just need to see uncertainty. Does anyone tackle the point of uncertainty in measurements? Do any of the examples have been presented today?
Yeah, so I must admit, in terms of the EOS context, a lot of what we're doing is working at a higher level than the units. So it hasn't really come up as much for us, but I think that data quality issue is really critical. And communities will have their methods of, showing how they've collected the data, how things have been calibrated to give a level of certainty to the units that have been measured. But a lot of what we've been working at is, the higher discoverability layers within EOS.
Yeah, so I think in the context of the metadata for machine workshops, we can get to quite low level and exact specifications on units for observed properties, and I could say the summary of my own presentation was really that as the concept of metadata for machine workshops is enjoying some kind of uptake in at least among funding agencies, that this is an opportunity also to find widespread reuse of FAIR systems of measure as well. So I'm just, I think the basic idea is we can piggyback existing systems of semantic units of measure to vehicles like the Metadata for Machine Workshop that are attempting to do this at a pretty large scale.
Yeah, I can perhaps add from the CIPM perspective. Of course, the uncertainty of measurement and the uncertainty in these type of data sets and so is something that I think the metrologists are really looking at. It's really one of our duties. So we hope that in the near future, there will be a lot of activity within the NMI community on that aspect. Thank you.
There is question about from Barbara. While I see the potential of QUDT, I find it hard to use it. It is hard to find what I need, and it is not well ingested in BioPortal. Many errors, missing concepts, the top RAID interface where the vocabulary is curated is not open for search for normal users. Any idea what I oversaw for better usage? Anyone would like to respond to this one? Maybe Simon, you would like to respond to this one, or Eric?
Yeah, I've just put that question in the backstage chat in case that helps
Okay.
Simon and Eric to see the question.
Okay, I can see the question now. Thank you. I couldn't hear it. Sorry about that. Yes, thanks. This question from Barbara.
Another question about is the mapping
QUDT.
exercise
yes, it is, not
openly
ideally.
accessible? Which
That I very much
semantic
agree with.
artifacts,
The individual
metadata standards are
resolved
being
nicely,
analyzed?
but there is not currently a public SPARQL endpoint, for example. There have been some issues with QUDT, some quality issues.
Would you like me to repeat
for example,
the question?
about its compatibility with Protege, and that's being fixed, actively fixed at the moment.
Yeah, Noah, I'm just quickly checking because it sounded like you could not hear Simon when he spoke. Can you hear me now?
Yes, I hear you.
Okay, so I think if you now, thank you, Simon, for that answer. I hope people heard it. And then Noah, you can proceed to the next question. I think you must just repeat the one that you just asked.
Okay. Is this mapping? sorry, another question. UM, QUDT, and QM are basically covering the needs of the most essential stakeholder communities. What could be the role of CIPM in respect to the definition of these systems for units?
Okay, I guess that question is for me
Yes.
because I'm a new CIPM member here. Look, we have this workshop to actually identify really what are there to be done by the CIPM, the International Metrology Community, the BIPM. And I can honestly say that I hope by the end of this workshop, we have a much better idea of exactly what our role is. But as you saw yesterday as well, the statements by our colleagues, Dr. Joachim Ulrich, and also OIML, Dr. Roman Swartz, we decided, or we are working together as scientific and legal metrology on these, but we invited the other international organizations that we really want to work with them. So my final reply is that we are now already, but also increasingly going to work with the other international organizations and explore how we can basically assist in doing exactly what this question asks. Of course, on our side, there are easy things to do very quickly, and that, for example, is to digitize the SI and make sure that the things that these standards need from us is in place. Thank you. And Noah, I think you're muted.
Sorry. So how much time do we have more? Okay, so we have we have a chance for more questions. Okay. Metrology is superior to the handling of data in any field and has to do with the generation, accuracy, and reliability of data, the use of a vocabulary that accurately defines the different metrological concepts, and the correct use of international system of units of measure if the data are not accurate and reliable. The interoperability of the data can lead to an expansion and globalization of errors. Do you agree with this? This is from Emilio Prito.
Well, I think it's a question to all of us, and we probably just can say yes. I definitely think that's correct. Thank you for the question. Any of the others that perhaps want to add to that from your experience?
You know, what we can say is, given the rich provenance metadata that is requested by the FAIR principles, indeed, that if we have a situation where there's a propagation of errors in whatever context, system of units or other kinds of spurious data, having that rich machine actionable metadata linked to those observations is at least an important way that we can begin to, later on assess these errors and try and correct them. So I think FAIRS is trying at least to help us to navigate a very complicated data landscape where uncertainties are sort of inherent.
Okay, there is a question from Leslie Bandrel. He speaks about uncertainty. Some ISO standardization groups currently working on harmonized concept systems for questions and units, quantities and units. ISO TC 37, language and terminology. ISO ICGTC 1/SC 32, data management and interchange. ISO/TC12, quantities and units, and ISO TC 215, health informatics. To all speakers, uncertainty is included in OWL.
Yeah, thank you. Thank you very much for that information, Leslie. Of course, we are working very closely with ISO, and many of our members are on your committees. Thank you very much. That's a good statement and good information. I don't know if any of the others want to respond as well.
Well, probably the main comment I would like to make is that on the one hand, the language and terminology are being teased out and standardized in these documents. On the other hand, much of the material that we've been describing in this session has been about converting that understanding from the text documents into machine readable forms. And that's the gap which I think we're this whole workshop, that's the gap which is the theme of what we're attempting to address here. So being able to fully capture and grasp the definitions, which are sometimes done in very nuanced, with a lot of diagrams, with symbols, with particular typography, which has been a rich thing in units of measure, and convert that into machine readable forms is certainly, that was the focus of the survey that I did of some of the existing systems.
Okay, thank you. And I have a question from Frank Heritage to Simon Cox. Thank you very much for your interesting contribution. In the Middle Ages, we had a huge contribution, amount of different measures and units. Now we have a huge amount of standards. Is there a chance to reach an agreement through the CIPM to bring about harmonization here before we be pushed back to a new Middle Age?
I don't think we're heading back to a new Middle Age. You know, I suppose the second to last slide in my talk was really addressing this issue, and was asking the question: is it feasible? Is it even desirable to force everyone to use a single system? Well, frankly, I don't think it's feasible. But I think because there's existing engineering, there's existing investment, and there's operating systems using the variety. But the variety is not that large. The variety is quite small. The number of systems which are rational and can at least claim to have some level of completeness and generality is manageable. And so my case really is, don't imagine that we're ever going to have a single standard, but try and make sure that we don't end up with 100. So somewhere between 100 and 1 is a good number, because we can manage mappings between a small number, recognizing that for cultural and engineering reasons, people will want to continue using the ones that they've developed until now.
Okay, thank you. And one question from Jörn Stinger to Sarah. Can you say in a nutshell how a sustained cooperation between metrology community and EOSC should be organized best?
Yeah, so I think working through various collaborators you have already. So CoData is heavily involved in EOSC, has done various kind of co-creation projects and initiatives that are feeding in. So I think working through those existing groups that you have to align with EOSC, and because EOSC is a federation of research clusters and communities, working through those research infrastructure projects where you have links there. I just wanted to reflect on that last question as well. Just the EOSC experience also shows that you can't force everybody to follow one standard. So I think we have to be willing to work with the existing standards, hopefully not proliferate them too much, but try and draw out commonalities and develop the crosswalk so that we're working with the different community practices.
Okay, thanks, Sarah. Another question, maybe the last according to our schedule, from Dr. Orlish. Question to all: how do you address data quality, uncertainty, traceability? Are there qualifiers?
Well, I think I mentioned earlier already the idea that in the larger context of machine actionable metadata, of which our systems of units may be, components of, that this should lead to those qualities mentioned in the question. So, for example, just by the simple fact that we were adopting the use of CDAR templates, already allowing us to be able to track canonical forms of metadata, even though they're very domain specific and were built for special purposes. And to the degree that those templates can more and more access vocabularies of systems of units semantic, then we begin to build up not only the measurements and their units, but also the cloud of metadata around them that helps us to track them and evaluate them over time.
Thank you very much, Eric, for that reply. Thank you, Dr. Noah, for leading this session. Well, basically, that brings us to the end of this first session, and we're now going to break. And then, according to the program, we restart at 10:20 UTC. So please check what is the time in your region. Central Africa and Europe is, of course, either 11:20 or 12:20. So please join us again then. Thank you very much, everyone, for this first session. A special thank you to our three speakers. Thank you.